Seeing is believing, or is it? Since the beginning of time, optical illusions have been observed. But how exactly do they work? Welcome to the science behind optical illusions. For the first illusion, you should stare into the central cross for 15 seconds. We'll start a timer for you. In a few moments, you'll see a negative after image, which is an illusion caused by the receptors in the back of your eye being desensitized. Now look at this masterpiece. Believe it or not, there are no colors on your screen right now. All the colors that you were just staring at are now inverted. When the color information goes to your brain, there is a rivalry between the complementary colors. And so when you stare at one color, that receptor gets desensitized or tired, so that when you look at a white screen, the receptors that are desensitized send less of a signal, and so you perceive the opposite color in its place. Here's a similar illusion. Do you think you can figure out how this one works? Let's start by staring at the center of this spinning spiral for 30 seconds. You should see that the rings are moving in a clockwise direction. Why do you think it is now moving in the opposite direction? This illusion is due to something called motion after effect. We have receptors that detect motion, and after viewing continuous motion for an extended period of time, the receptors that detect motion in that direction become less sensitive, so that when the video stops moving, the neurons that detect motion in the opposite direction are more active in comparison. This results in the appearance of movement in the opposite direction. It works the same way as the color after effect, except now we have motion detectors. Fun fact, one of our first records of this being observed was by ancient Greek philosopher Aristotle, who noticed that after looking at a rapidly flowing river for a while, nearby stationary objects appeared to be moving. Next up, do these rings look like they're jumping off the page? This 3D effect is called Chromostereopsis, and it is caused by the law of refraction, which means that different colors of light bend at different angles. It's the same law that happens when light goes through a glass prism and splits into a rainbow. In this example, the red light is bent less and the blue light is bent more, making it land on different parts of the back of the eye. This is the same information that gives depth perception, which is why different colors on the same screen appear closer and further. No 3D glasses needed. Now we've walked you through a few of our favorite optical illusions. It goes to show that there is much more going on to perception than meets the eye. So next time you think your eyes are playing tricks on you, well, they just might be. This video is brought to you by UW Chaos. Thank you for watching.